Hello, Year 10. Today we'll be looking at Pythagoras' theorem, which will include some three-dimensional problems, but let's quickly review some perimeter questions from last lesson. To find the perimeter of the shape in question number 1, we want to find the perimeter of the half a circle that we have here. Now, for that circle, I know that its diameter would be 5 because of this side length here. So I'll do P for perimeter equals, it's half of a circle, so I'll do half of pi d. Then I will need to still add on the straight sides to close in the rest of that shape. So I'll be adding on 2 lots of 2.5 plus the 1/5 for that long side there. Subbing in my diameter, I have half times pi times 5 for the diameter of the circle, plus all of those other things that aren't going to change, and then we type it in our calculator. However, it does say that I want the exact perimeter, so to type it in, we're going to have to do the two terms separately. And the first one, you're doing half times 5. Now, half times 5 as a fraction is 5 over 2. So it will be 5, put the pi back in, so 5 pi over 2. Then plus, work out the second term, we have 2 times 2.5 plus 5, which makes 10. So the perimeter would be 5 pi over 2 plus 10 meters. Question 2 says, find the value of x if the perimeter is 10.8. So if 10.8 is the perimeter, that's going to be equal to all of these sides added together. And how many x's do we have here? We have 1 plus another 2, that's 3, plus another 1.5. We have 4.5 x's. And then I just solve the equation to find out what x is. So we divide by 4.5. X is by itself. 10.8 divided by 4.5 gives 2.4. Okay, Pythagoras' theorem time. So the original formula for Pythagoras' theorem is that the hypotenuse squared is equal to a squared plus b squared, where a and b are the two shorter sides in your right angled triangle. However, for most people, you may prefer to rearrange the formula so that you have these two here below. This formula has been rearranged to get the h by itself, so you're just square rooting the other side. And the one underneath that, this formula is used if you want to find one of the shorter sides. Okay, so it's up to you. You may have a preference whether you like to use this one up the top here for everything, or this formula for finding the hypotenuse, this one for finding a shorter side. Question 1. Find the side length for each of the following right-angled triangles, correct to 1 decimal place. So when I look at question 1a, I can see that I've got my right angle here. I have the two shorter sides next to the right angle. I am missing the hypotenuse. So that means I'm going to use the hypotenuse formula, which is h equals square root of a squared plus b squared. Subbing into that formula, the side I'm trying to find, even though it's the hypotenuse, it's called x. So I'm going to do x equals big square root. The a and the b, it doesn't really matter which number is which, so I'm going to do 20 squared plus 21 squared. And then we type it into our calculator to get the answer. To 1 decimal place, there is no decimal places, so we just do 29. Let's do another one, question 2. We have got one of the sides next to the right angle missing, which means we're missing one of the shorter sides. To find it, we use the shorter side formula, which is a equals square root of h squared minus b squared. Subbing in, x is the name of my shorter side, equals square root of the hypotenuse has to be the longer side, so 24 has to go first, and then minus 19 squared. Type it in. We get 14.7 to 1 decimal place. Question 3 is a three-dimensional question, but sometimes these just look complicated and they're not as bad as they look. So let's have a read. The length of the diagonal of the base of a rectangle is 7.4. That's this one across here. The height of the prism is 4.2. Find the distance from one corner of the rectangle to the opposite corner. Give your answer correct to 3 significant figures. So even though it's in a rectangular prism, it is still a right angle triangle that I'm working with in here, and I'm trying to find the hypotenuse. So I just have to use my formula. H equals square root a squared plus b squared. The a and the b will be 7.4 squared and 4.2 squared. And then we type that in. Okay, so there's the answer, but we want 3 significant figures, which means we want the 8, the 5, and the 0, but the 0 will round up to be a 1 because of the 8 that's afterwards. So 8.51 meters to 3 significant figures. Question 4. Use Pythagoras' theorem to determine whether the following triangle is right-angled. It looks right-angled, but that's not good enough. We need to know, with some mathematical evidence, whether it is right-angled or not. Now, if it is right-angled, it should obey Pythagoras' theorem. And Pythagoras' theorem says that the longest side squared must be equal to the 2 shorter sides squared and added together. Now, is that statement true or false is what you need to ask yourself. So let's find out. 13 squared is 169 on the left side. On the right side, 5 squared plus 12 squared also equals 169. So because they were equal, this means that it is a right-angled triangle. If they were even the slightest, tiniest bit different, even a couple of decimal points, that would mean that it is not a perfect right-angled triangle. Question 5. Find the value of x correct to 2 decimal places. Okay, so this is a rectangular base pyramid, and we have x over here on this sloping height. To find x, I'm going to need to construct a line that goes through the base of my pyramid like that. If I can find that side using the 1.5 and the 3, which I can. So this is a 3-dimensional diagram, but this would have to be a rectangle on the bottom, which means that this is a right angle. Which means if I use Pythagoras' theorem, that full side there, I'm going to call h. I can find that side first. Finding h with my formula. H equals square root of a squared plus b squared. Subbing in, I would get 1.5 squared plus 3 squared. Okay, that equals 1.5 squared plus 3 squared equals. Now, even though the question says 2 decimal places, that's for the final answer. If I have to do lots of squaring and multiplying and other things still in another part of this question, I don't want to round too early. So I'm going to keep 4 decimal places here just to be safe. So it's 3.3541. Okay, now to find the height of that sloping height, x, that I want, I have, I'll change colours, I have the perpendicular height of my pyramid, if I halve that base that I just found, I would know that side across the bottom. Here would be my right angle. And then I'd be finding the hypotenuse of that triangle, the green triangle. Okay, so this side down the bottom will be half of the 3.3541. So we've still got that number in the calculator. Let's just divide it by 2. And that's 1.677. Okay, so now let's do Pythagoras' theorem again, finding the hypotenuse to find out what x is. So the hypotenuse is x. X equals square root of 1.677 squared plus 2 squared. In the calculator, we get 2.61. We're rounding to 2 decimal places for the final answer. Question 6. Find the exact value of x. And there's 2 of them. There's one here and there's one there. Okay, so using the traditional formula for Pythagoras' theorem, the hypotenuse, which is 25 squared, is equal to the 2 shorter sides squared added together. So it would be x squared plus the other side is 2x, which also needs to be squared. It's important that you put that 2x in brackets because you have to square the 2 and the x. So it will become 625, which is 25 squared, equals x squared plus 4x squared, squaring that 2. X squared plus 4x squared makes 5x squared. Dividing by 5, we get x squared equals 125. To get rid of the squared, we will square root the 125. Only the positive version because we're talking about the side of a triangle, so you can't have a negative side length. That surd can be simplified. 125 is the same as 25 times 5. So I split the surd, and the square root of 25 is 5 root 5 centimetres. So there is the exact value of x in simplified surd form. It's a very good question. All right, you can now do exercise 4F.